Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 10 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3440, reschedule meetings for maximum free time 2. So you are given an integer event time denoting the duration of an event. Okay, you are also given two integer arrays, start time and end time, each of length n. All right, so here see event example number 1, event time is 5, so this is the total duration. Okay, 0 to 5, right? And now if you see, we have start time and end time, so both are having length 2, right? So that simply means two number of meetings are there. So one meeting is from 1 to 2, okay, let's say A, and then the next meeting is from 3 to 5, okay, let's say B, right? So here B. Okay, so these represent the start and end times of n non-overlapping, okay, non-overlapping meetings that occur during the event between time t is equal to 0 and time t is equal to event time, where the ith meeting occurs during the time start time of I to end time of I. Okay, you can reschedule at most one meeting by moving its start time while maintaining the same duration, okay, such that the meetings remain non-overlapping to maximize the longest continuous period of free time during the event. Okay, we have to return the maximum amount of free time possible after rearranging the meetings. Note that the meetings cannot be rescheduled to a time outside the event, and they should remain non-overlapping. Okay, in this version, it is valid for the relative ordering of the meetings to change after rescheduling one meeting. Okay, so in part 1, the relative ordering, it was given that relative ordering of the meeting should not change. Okay, so here if green comes first, then yellow, then red, so we have to maintain that order in part 1 of this problem. Okay, but in part 2 this doesn't matter. Okay, so I can place this green here in between these two. Okay, so now if you see the order, yellow, green and red. Okay, so we can do this. All right, so this is one change in part 2. Okay, and in part 1, k value was given to us, right? So we can reschedule at most k meetings, but in this we can reschedule at most one meeting only. Okay, so I have already solved the part 1 of this problem. Okay, so I will add the link to part 1 in the description of this video. Okay, you can check that as well. All right, so now let's come to this problem now. So see this example number 1, event time 5, so means 0 to 5, start time and end time 1 to 2, there is one meeting, and end time here 3 to 5, there is one more meeting. Okay, so here 1 to 2 I can place this meeting here. Okay, only two meetings, so this is here to the extreme left, this is here to the extreme right. So in between, if you see the time 3 minus 1, 2. Okay, 2 is output. Okay, or you can place this meeting here also, 2 to 3, and then this is the free time, 2 minus 0. Okay, it's 2. Okay, so whatever you want, right? So output is 2. Okay, here example number 2, here you can place this 0 to 1. Okay, here in between. Okay, so duration is 1, so here also the duration is going to be 1 only, right? And the meetings are non-overlapping. All right, so now here 7 to 0, 7 minus 0, the output is 7. Okay, so 0 to 1 to 8 to 9, leaving no meetings during the time 0 to 7, so that is why output is 7. Okay, clear, right? Okay, now understand with this example. Okay, so from here you will get clear idea. All right, so now here let's first see this meeting m0. Okay, this meeting m0. All right, so now here if I place this meeting m0, okay, so if the relative ordering matters, okay, so what will happen? So let's suppose if I place my m0 to right now, if you see, just see this part. Okay, just see this part. So right now we have to return the max free time. Okay, so g0 or this g1, okay, whatever the max, that is what we are going to return. Okay, right now in this part. Okay, but now if I place my m0 here, okay, m0 here, then here I what is the gap that I have? G0 plus G1. Okay, this is the gap I have. Okay, so this is definitely bigger than just G0 or G1. Okay, G0 plus G1 is definitely bigger than this single G0 or G1. Okay, so this is the max free time. Okay, so I am placing M0 here only. Okay, in this part only right now. Okay, in order to maintain the relative ordering, but in this problem it is given that relative ordering doesn't matter. Okay, so now let's suppose if I place this M0, okay, instead of here I place this, let's say this M0 size is 2, okay, and here if you see this gap 2, here size is 2, okay. So let's say I place my M0 here, okay, I can place, right, gap is all right. So now what will happen in this case? So now I'm removing the meeting itself, okay. So now if you just see this particular space, so my free time is G0 plus G1 plus M0, okay. So M0 also contributes towards the free space, okay. So this is bigger, right? So now from here what I conclude, I conclude here that if I move my meeting, okay, if I can move my meeting outside, okay, at most only one meeting I can move, okay. So if I move my meeting M0 outside, okay, to any other adjacent meetings, then I will get to the max free space, right? This is what I conclude here. So here what I'm going to do, I'm going to check if meeting can be moved, okay. If it's true, then this is the total output that I have, and if it cannot be moved, then this is the total space, okay. So I will check all these things, okay. So I will just find out the max value, okay. I have to check for M0, okay, M0 can be moved, then I will check for M1, okay, M1 can be moved, okay. And I have two options, right, for one meeting to be moved, okay. So M1, I don't want to place my M1 here or here, okay. If I place my M1 here, okay, to left to this right, okay, then the space I'm going to get G1 G2, okay. I'm thinking about placing this M1 outside this M0, okay, to the left of M0 or to the right of this M2, okay. So what I'm going to do, I have two options for this M1. I can place to the left or I can place to the right, wherever it fits, okay, making sure that in between 0 to 25 of 25 only, right, and it should be non-overlapping, okay. So these are two options. So I will check the left space, okay. So for M1, is there any left space where I can fit this M1? For M2, is there any left space where I can fit? For M3, is there any left space where I can fit it? For M4, is there any left space where we can fit it? Okay, this is for left side. Then same way, I have to check the right space also. So M4, if there is any right space where I can fit it, okay. If for M3, is there any right space if I can fit it, okay. So I have to check both left spaces and right spaces, okay. And then I will just create one variable can be moved, okay, let's say. So I will make sure whatever the meetings that I can move, okay. So if the value is true, then I'm going to, let's suppose if I can move this M3 outside, so I simply calculate this as free time, okay, G3 plus M3 plus G4, okay. So that's what we need to do, right? Very simple, okay. So this is done. So now let's write the code, and with code also I am going to explain side by side, okay. But this is the basic idea to solve this problem, okay. So let's write the code, nothing complex here. All right, so first thing that you need to do here, first let's calculate the length, okay, number of meetings. So start time and event end time are having same number of length, okay, and it just shows the number of meetings, okay. So I can say int n is equal to start time dot length, okay, done. And then can be moved I, okay, I'm going to create this array, so it will be true if the ith meeting can be rescheduled to another position, okay. So I'm going to say boolean can be moved is equal to new boolean and here n, all right, and max left gap, okay, max left gap, okay. So at most only one meeting I can move, right. So for this M3 I will just find out the max free gap, okay. So G2 G1 and G1 or G0, okay, G0 G1 and G2, whatever the max gap here. So wherever the max gap I will just fit it, right. So that is the best case, okay. I don't want to take smaller gap, because let's suppose G0 is 1, then I can't fit this M3, okay, of size 3, okay. So I need the max gap only, right. Okay, so that is why max left gap I'm creating this variable, right. And same way max right gap, okay, I'm going to set it to 0, okay. Now first pass from left to right and then from right to left, okay. Two things we need to check, okay. So for int I is equal to 0, I is less than n I plus plus, okay. So first left duration. Okay, so for first, this is a meeting, right? So what is the duration of this? So end time of this meeting minus start time of this meeting. Okay, 4 minus 2, that is 2. Okay, so 2 is the duration. All right, so here I am going to say left duration. All right, so here I'm going to say end time of I minus start time of I. Done. Now we have to try to move this meeting of I to the left side, okay, as early as possible. Okay, that's what I'm going to check. Left side. Okay, so here first thing, can it be moved? Okay, but I don't see any other meetings here, right? So I am going to let it be false. Okay, so by default all these values are false, okay, initially, right? In Java all these values are false initially, right? So here I'm going to check if the left duration, okay, is less than equal to my max left gap. Okay, so left duration right now, if you see here, it is 2. Okay, and max left gap is 0. Okay, so 2 is less than equal to 0. No, right? So that simply means that I can't move this meeting, okay, anywhere outside. Okay, so it will take this gap only, right? So I'm just taking left side. Okay, so I can only place here then G0 plus G1 only. Okay, I'm not going to place outside, okay, right now. So what I'm going to do here, uh this, okay, so definitely 2 is not less than equal to 0, right? So here, if this is not the case, then can be moved, I will set to true. Okay, so right now it will remain false only, right, for this particular example, for this particular meeting, right? So 2 is less than equal to 0, false. So definitely I'm not going to execute this right now. Okay, so this is done. So now we have to update the max free time to the left. Okay, so I check this. So now when I'm going to check for M1, I need to make sure this gap of, okay, G0, and for M1 I'm dealing with just G0. Okay, so for M1 I'm going to check if I can place this M1 here at this G0. Okay, so what I'm going to do, if right now my I value equal to 0, okay, if my I is equal to 0 only right now, okay, so free time I can say max left gap. Okay, I can say max left gap is nothing but the start time of this, okay, minus 0. Okay, minus 0 because it is starting from 0, right? So start time of this meeting M0 and here 0. Okay, so I can simply write here start time of I minus 0. Why I'm writing 0? No need, right? I can remove this, right? So I can simply say start time of I. Okay, so gap from 0 to start of the first meeting, right? Done. And in the else part, okay, so now next time, how I'm going to update my max left gap. Okay, so if my I is not equal to 0, okay, so in that case max left gap, okay, so I can say math dot max of the max left gap. Okay, and here how I'm going to deal with max left gap. Okay, so let's suppose right now I'm for this meeting, okay, for this meeting, okay, once I cover this, so now how I'm going to deal with that, so simply going to write here the start time of I. Okay, start time of I, okay, minus, okay, start time of this meeting, let's say M1, okay, this minus end time of I minus 1, and time of I minus 1. Okay, so what I'm doing here for M1, if you see, so this gap I already know. Okay, this gap value is already stored in the my max left gap. Okay, and now the new gap for that I am going to take here G1. Okay, so G1 is nothing but the start time of M1 minus end time of M0. Okay, so that is why I minus 1. Done. Clear? Okay, this is done. Now we have to do the same thing. Okay, this is done here. Now we have to do the same for the right. Okay, same from the right. Okay, so I'm going to create one variable int j, and I'm going to set j as n minus I minus 1. Okay, so here when my I is 0, then j is n minus 1 last. Okay, when my I is 1, so j is n minus 2. Okay, so that means second from the last. Okay, so that is valid. Okay, so when my I is 0, when my I is equal to 0, then I'm taking j as n minus I minus 1. Okay, n is nothing but 5. So 5 minus 1 minus 0 minus 1 is nothing but 4. Okay, so that means 0 1 2 3 4. That's it, means this one. Okay, this fourth, right? M4 meeting. Okay, for I0, then I'm taking this as right. Okay, when my I here, then I'm taking this. When my I here, I'm taking this. Okay, then my I here, I'm taking this. Okay, like that. When my I here, I'm taking J as this. Okay, so in single loop I'm going to cover everything. Okay, so this is done. So now here, let me just simple copy this. Okay, paste it here. Now write duration you are dealing with, right? So here int write duration is nothing but you can simply say write duration is equal to n time of j minus start time of j. Okay, so for this, okay, n time of this, start time of this. All right, and now how you are going to update your I'm dealing with the write duration. Okay, so here let me just copy this, right? Okay, so here write duration. Okay, so write duration value, if this write duration value is less than max write group. Okay, max write gap. Okay, max write gap. Okay, then in that case, can we move j value? I'm going to update it to true. Okay, so right now if you see, first I'm covering left. Okay, left to right, then right to left. Okay, so in left to right I already it was false. Okay, in left to right it was already marked as true. Okay, in left to right it was already marked as true, if you see, because m4 I can move it somewhere here. Let's say g3 I can move here, right? I can move this m4 here also, g1. Okay, so I can move. So now I'm checking from right to left. So you say that in the right side we can't move. Yes, in the right side we can't move. Okay, because there is no meeting here, right? And here in the right side we can't move, right? But in the left side we can move now, and in the left side we have already checked. So this is already marked as true. Okay, so let me show you in the left pass. Okay, left pass. Okay, can we move the meetings to the left side? Okay, so m0 we have meetings m0. All right, we have meetings m1, m2, m3, and m4. Okay, so m0 we can't move, right? It will remain false. Okay, m1 we can move. Okay, true. M2 we can move, right? M3 we can't move. Reason is 16 minus 13. 16 minus 13, size is 3. Okay, g2 is not 3, g1 is not 3, g0 is not 3. Okay, all are 2 only, right? Gaps. If you see 16 minus 13, 3, and here 10 minus 8, 2 gap. Okay, this gap is not enough, so I can't move this m3. Okay, right outside. M4 I can move. Okay, true. Now for the right pass I'm checking. Okay, right pass. Okay, what is going to happen? This is already true now, so I'm not going to do, I can't do anything. Okay, right duration is less than equal to max right gap. So you are going to say right duration is 0, max right gap, or max right gap is 0, right duration is 2. Okay, so 2 less than equal to 0, false. But this value already is true. Okay, in my left pass. Okay, this pass, right? So I am not able to, I'm not going to execute this. Okay, it will not be executed, but it's still true. Okay, and then here after that, here I'm going to write if j value. Okay, if j is equal to last, okay, n minus 1, same like left to I'm doing, j is equal to n minus 1, then right gap max right gap is equal to uh, not start time. Now this is going to be total event time. Okay, 25 minus this end time. Okay, end time of m4. Okay, so here I'm going to say uh, end time of j, right? And okay, end time of j, and here I'm going to write event time. Okay, event time minus end time of j. Okay, gap from the end of the last meeting to event end. Okay, and else I'm going to update my max right gap as max of max right gap. Okay, so for this meeting if I need to check, so this gap I already have, and for this one, this minus this. Okay, so this is nothing but the start time of next meeting and end time of current. Okay, so here start time of I can say j plus 1, right? Next one. Okay, j plus 1, and here minus end time of j. That's it. Okay, so very simple thing that I'm doing here. All right, so this is done here. Okay, so our for loop is completed here. Okay, so that's it, that's it. All right, so this and here true, so m3 I can move now. Okay, previously it was false, but in the right side I can move m3. Okay, so this gap g5 is very big, 5. Okay, 5, 25 minus 25, so I will set it to true. This will be true, this will be true, and this m0 is also true. Okay, I can move this m0 now to the right. Okay, so first I was checking just for left, left, left. Now I'm checking for right, right, right. Okay, so in the end all these values will be true. Can we move values to be true? Okay, so this is what happens. Okay, that's it. Okay, now after this, once this is done, now we have to compute the maximum free time after possibly moving one meeting. Okay, so now let's create one variable int max free time. Okay, and here set it to 0, and now run one loop int I is equal to 0, I is less than n, and here I plus plus. Okay, and now inside this just check if int left. Okay, int left variable. Okay, so if I value is equal to 0, right, so in that case we have to take 0 only, right? Otherwise we have to take n time I minus 1. Okay, n time I minus 1. Okay, I minus 1. All right, and here int right. Okay, int right is equal to, okay, so if my I value is equal to n minus 1, okay, that's it means last meeting. Okay, so in that case I'm going to take the right part as event time. Okay, the last point. Okay, event time. Okay, so I'm talking about extreme left and right to the that meeting. Okay, otherwise I will take here spelling mistake, I think, event time, and here you have to take a start time of I plus 1. Okay, so this is done. So here what I'm saying, if this is the meeting, okay, I is equal to 0, m0 means I is equal to 0. Okay, let's say, so first meeting, so then this is the left. Okay, for this, but if m1 is there, then this is the left for this one. Okay, this one is the left. Okay, ending of this m0. Okay, so that is why n time I minus 1. Okay, same way for right, if the last meeting m4, then I can simply pick this. Okay, but if m3 is there, then I have to take the next meeting's start time. Okay, so here start time of I plus 1. Done. Clear? All right, so now here how I'm going to calculate the mac meeting duration. So meeting duration of the current meeting. Okay, the meeting on which I have. Okay, in which I am, right? So meeting duration is equal to end time of that meeting and start time of that meeting. Okay, simple. And time of I minus start time of I. Okay, this is done. All right, so this is done. Now here simple, I am going to check if can be moved. Okay, I can move this meeting, or can be moved I. Okay, so in that case we can move this meeting, so the whole gap becomes free. Okay, so if I am going to move this meeting m0, then this complete gap is free for me. Okay, g0 plus g1 plus m0. So for this m0, my left is 0, my right is this 6. Okay, so 6 minus 0, 6 is the value, right? So here what I'm going to do, this is what I need to calculate max free time. Okay, and I need max. Okay, every time, so math dot max of max free time, and here I can simply do right minus left. That's it, right minus left for this correct meeting. Okay, but if it cannot be moved, okay, then also I'm just going, then free time. Okay, then free time is going to be this g0 plus g1 only. Okay, and I have to subtract this m0 duration, right? So I'm going to say int free time is going to be, free time is going to be right minus left. Okay, but from this right minus left I have to subtract the meeting duration. Okay, so meeting duration I can say, easy, right? And now again I have to update my max free time. So this is nothing but max free time is equal to math.max of max free time, and here the value that I calculated here. That's it. Okay, very simple. That's it. Okay, that's it. We are done with this problem. Now from here you have to simply return max free time. That's it, max free time. All right. Okay, now let's run the code and see if there any code issues. We'll try to fix that. So, wow, nice. Okay, so all the test cases has been accepted, right? So here this case 5, if you see this, okay, 9 is the output. Okay, so when you are going to get 9, I think when you are going to move this M4 outside, okay, here somewhere, right? So now if you see 1625, okay, this gap, so 1625 is nothing but 9. 25 minus 16, if you do 9. Okay, nice. All right, so that is done. Okay, now let's submit it and see if there are any other issues. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.